Math 8, Unit 4, Graphing and Slope, Lesson 3, Part 1. Determine slope from various given information. Alright, I can determine slope given various information. So here's the rundown. First, slope is a number that describes the steepness of a line. That's important to understand. First, we're going to talk about how to do it from a graph. From a graph, you're going to use rise over run. And on the graph, you can draw a little right triangle, and then you can see your rise is how much you change going up or down, and run is how much you change going left or right. And they can be negative if they are if they're going down or if they're going to the left. The second, from a table, you'll do change in y over change in x. Here's an example over here. We've got a table with x and y. You can see the x's each time go up by 2, and the y's go up by 4. So the change in y is 4, the change in x is 2, so the slope is 4 over 2, which equals 2. The third way we're going to talk about today is from a pair of points, x1, y1, and x2, y2. The slope is going to be the change in y over change in x, or for a more general formula, see the little triangle, that's the Greek letter delta. It means change in, delta y over delta x. Anyway, y2 minus y1 over x2 minus x1. y2 is the y coordinate in the second point, and y1 is the y coordinate in the first point. So on top I get 1 minus 4. And in bottom I get x2, which is negative 2, minus x1, which is 3. And I get negative 2 minus 3 on bottom. That gives me negative 3 over negative 5, which is 3/5. The important thing here, the points are interchangeable. So this could very well be y1 minus y2 over x1 minus x2. The order isn't going to matter, because if you did it in the other order, you just change the signs on top and bottom. If you change the signs twice, you'll get the same sign you started with. Okay, we're going to be looking at several examples of finding slope from these forms. Okay, first from a graph. You'll want to draw a triangle, a right triangle that encompasses both points. This is going forward 1, and this goes down 3. The rise here is a negative rise of 3. The run is 1. And this gives us an overall slope of negative 3. Next example. We're going to draw a right triangle between the 2 points. Now we need to figure out distances here. This moves over 5 and up 4, giving us a slope of rise over run, 4 over 5. And then we'll just leave it as that fraction, 4/5. That is the slope of our line. Next, this one does not have any points drawn, but there are some really nice lattice points that we can use. These are places where the line crosses, they cross at a point in the grid where 4 squares come together. But anyway, this right here, it looks like if we draw a right triangle, it can be between any of the 2 points. To get from 4 up to 12 is a rise of 8. To get from 1 to 3 is a run of 2. This gives us a rise of 8 and a run of 2. And that is a slope of 4. Now in this case, the slope actually has additional meaning. It's for, we have y on top, so that's bracelets, per x is girl, so it's 4 bracelets per girl. Alright, let's do it from a pair of points. When we have a pair of points, we need to identify our x's and y's. Let's call this x1 and x2, this y1 and y2. So the slope is y2 minus y1 on top, so negative 4 minus 3 on top, And on bottom, it's going to be 7 minus 6. Negative 4 minus 3, they're both negative, so we add them together and get negative 7. 7 minus 6 is 1. This gives us a slope of negative 7. Okay, example 5. Negative 9, negative 3, and negative 7, negative 5. Okay, we'll call this x1, y1, and x2, y2. Now, I mentioned that it can be done in a different order. So you could do y1 minus y2, and you'd have to do x1 minus x2 on bottom. The important thing is that they line up. You're always going to put your y's on top and your x's on bottom. So my y's are negative 3 and negative 5. My x's, if I go in the exact same order, since I started with negative 3, I'd have to start with negative 9 because it's in the same point. And I'll go negative 9 minus negative 7. Now, we know from what we learned in 7th grade about integers that when we subtract a negative, we can add the opposite. So we'll want to do that on both bottom and top. Negative 3 plus 5 is 2. Negative 9 plus 7 is negative 2. And 2 divided by negative 2 is negative 1. So the slope between these 2 points is negative 1. Next example. Between 6, negative 2 and 5, negative 4. Well, the slope, putting the y's on top, negative 2 minus negative 4. Putting the x's on bottom in the same order is 6 minus 5. When you see minus negative, you want to change it to add the opposite. Negative 2 plus 4 is 2. 6 minus 5 is 1. Slope is 2. Next example. The slope is going to be y2 minus y1. I'll go ahead and go in this direction this time. So the y2 minus y1. 8 minus negative 4. And on bottom, the x's, 4 minus 7. 8 minus negative 4 is going to be 12. 4 minus 7 is negative 3. 12 divided by negative 3 is going to be negative 4. So my slope is negative 4. Next example, negative 7, 8 and negative 7, 5. Okay, the slope is going to be y2 minus y1 over x2 minus x1. I see minus negative, so I'm going to change it to plus plus. 5 minus 8 is negative 3, and negative 7 plus 7 is 0. Now, we are not able to divide by 0. Divided by 0 is undefined, so the slope of this line is undefined. An undefined slope means that it's going to be a vertical line. Okay, next example, 5, 9, and 3, 9. All right, our slope is the change in y. We'll do y1 minus y2 this time, and x1 minus x2. As long as we go in the same order, we're in good shape. On top, 9 minus 9 is 0. 5 minus 3 is 2. 0 divided by 2 is just 0. So a couple special things here. It looks like if the x's are the same, it's undefined, and this would actually kind of make sense. These 2 points are straight up and down from each other at negative 7, 5 and negative 7, 8. If both of the y's are the same, we get a horizontal line. So 5, 9, and 3, 9 would give us a horizontal line, and therefore having a slope of 0. Okay, from a table, remember on a table you need to find change in y, which it looks like these are going up by 7. We don't necessarily have to check all of them. From 7 to 14 is going up 7. 14 to 21 is going up 7. The slope is the change in y over the change in x. The change in y, it's going up by 7 each time. The change in x, it's going up by 7 each time. This gives us a slope of 1. And actually, since this one has units, this is actually 1 inch per day. Slope doesn't necessarily need units, but slope does closely relate to unit rate. Okay, the number of hours worked and the money earned. It looks like as we move up here, we are adding 40 each time. As we move up here, we're adding 2. So the slope, change in y, 40, over change in x, 2, gives us a slope of 20. And as a unit rate, that's $20 per hour. Okay. Back to, we actually did this one in the previous video. You can go back and watch the video from the previous lesson on finding slope from graphs. We did all 3 of those examples as well. This is just another example. You can actually take a graph like this and use the points into the slope formula, and it'll give you the same slope as if you do the right triangle thing. Same thing with a vertical line. Okay, find the slope through the given points. I think I've done plenty of examples there, so I'm going to go ahead and skip over those for now. On the table, remember that we want the change in x. You only have to check it once, actually. You don't have to check it on every one of them. The change in y is to go down to. This gives us a slope of -2/3. Right here, the change in x is going up 2. The change in y is going up 3. So this gives us a change in y over change in x of 3/2. So our slope is 3/2. Right here, from 6 to 4 is going down 2. From -3 to 2 is going up 1. This is a slope of -2 over 1, which is just -2. In summary, you've got positive slopes, negative slopes, slope of 0 and undefined. And I think we've kind of seen what these look like in the different situations. I haven't actually looked at a table on the undefined slope and the slope of 0. But on a graph, this is what they look like. On a table, a slope of 0 would allow x to be a bunch of different things, but y would all be the same. That would give you a slope of 0. If it's a set of points, all it has to do is have both y's be the same. For undefined slope on a table, it would have several different available values for y, but the x's would all have to be the same. And if it's a set of points, it's just going to have both x's the same, and that will give you a vertical line.